So this is actually a really good question to review just because a lot of times it's just what makes this question confusing is just not realizing that this is actually what would show up on a label. The reason we didn't reprint the label is because the label is so small. I just gave you what would be found on the label. So without even looking at the question, when you look at this here, for when we're talking about drug calc, I need two pieces of information. I need my order, and I need a way to convert that order, in this instance for units, into what I want, which is milliliters. And so you can see here units per milliliter solution. So without doing anything else, just know that that's what you would focus on for this type of question. Now, why ignore this column? Well, you are going to ignore this column because all this does is tells the pharmacy how much deionized water to add to the powder to get to this concentration, or this concentration. The second step to this question is, okay, well then what do I do? Like, which do I choose? And then that's the question actually says to choose the strongest concentration. So it says there, choose the strongest concentration. So which of these three is the strongest? 250, 500, or 1 million? And the answer is the 1 million. So to solve this question, you just need to first realize that this is extra information and doesn't help you to solve the equation. It just tells you how to get to the dilution factors, which are already listed for you.
Okay.
Yeah. And then it's just a matter of taking your 750,000 units. And then I always show this from the standpoint of dimensional analysis. And then if you ever have all these many zeros, and you will have a question like this, just take the smallest number. So there's 4 here and there's 6 here. So I'm going to take 4 away and I'm going to take 4 away. 75 over 100. You're less likely to make mistakes on when you're plugging that into a calculator. And then you leave your answer as 0.75. Because a number less than 1, you round to the nearest hundredth place.
Would that be in milliliters, please?
Correct. Yeah.
Okay.
Yeah, because it asked how many milliliters will you administer. So yes. I just ran out of room.
Thank you.
You're welcome.
I'm sorry, I just came in. Is this the first question you solved?
Yeah, this is the first question that was asked. Yes.
Okay, good. I mean, the first question you solved, like the first question you worked on.
Correct. Yes.
Okay. Thank you.
I need my flow rate and I need a drop factor. When I have those two pieces of information, that will give me my drop rate. You might just have to change your flow rate from milliliters per hour to milliliters per minute, or vice versa. Sometimes it's already given to you in minutes, and so you just leave it alone. So this particular question says that the physician ordered 1440 cc's to be infused over 12 hours. And then your tubing is labeled as below. And you can see that big number 10 there. And it tells you 10 drops per milliliter. So my flow rate is the 1440 cc's and 12 hours. Now, and then our drop factor is 10. Now, you can continue this, and you can do dimensional analysis to convert hours to minutes. Or what I typically like to do is, because I know that 1 hour is 60 minutes, all I'm going to do is multiply 12 times 60. So I'm just going to kind of create an aside. I'm going to multiply by 60, and I'm going to get 720 minutes. And so what I'm going to do is I'm just going to replace what I have there for 72 hours with 720 minutes. Okay. Then all I need to do is 1440 times 10 divided by 720, and you get 20 drops per minute. The other way that you could do this is you can just right off the bat, 1440 divided by 12. And I think that comes out to, instead of thinking what it comes out to, let me just put it in my calculator. Comes out to 120. So you could have started off after reducing that to 120 milliliter per hour. And then you know that 1 hour is what? 60 minutes, right? Times the 10 drops per milliliter. And you still get the same answer. You'll still get 20 drops.
I'm sorry, what from the 120 milliliters?
I just reduced the 1440 over 12.
Oh, okay.
So
12
I was
by
given 1440
Okay.
cc's over 12 hours.
Okay.
And that's the same thing as 120 over 1. Yeah, so.
Okay. Okay.
Yeah, all I did was reduce it. So 1440
Yeah.
divided by 12. You got it.
Yeah, and cc is the same as milliliters. Okay.
Yes. Well, I'm sorry, I meant hour.
Okay.
This question, number 19, is actually commonly missed because it doesn't seem like you look for more to do than what is actually, and all it is reducing your volume over time. So keep in mind, what is flow rate? Flow rate is milliliters per hour, okay? If I say drop rate, it's drops per minute. So what do I have here? It says the patient's to receive 375 milliliters of Ringer's lactate over 3 hours. And then what would you set the infusion pump to? So I'm just going to take my 375 milliliters. I'm going to take my 3 hours. In my calculator, I'm going to do 375 divided by 3, and I will get 125 milliliter per hour. I think a lot of times people want to do more than what needs to be done here, but this is all they're asking you to do. The other variations of this is they might say the same quantity, 375 milliliters, but maybe over 30 minutes. Then what would you plug into the infusion pump then? Or maybe it's say 15 minutes or 45 minutes. And then you just calculate. And at that point, if you have milliliters per minute, you just convert minutes to hours.
Okay. Okay. So assuming they say 30 minutes, you will convert 30 minutes to hours and divide it by 375 milliliters.
So let me just do an example. So this is not 19. Okay, I'm going to do a different question now. Okay, so we're just going to separate this. Let's just say I am ordered to infuse 120 milliliters in and then to do that in 45 minutes. Okay, I'm just making this up on the fly. I'm not sure how this is going to work out, but we're going to do it anyways. So there are ways that you can figure out what this is, but the most direct way is just convert minutes to hours. Okay. And again, one of the main reasons I always like to do the dimensional analysis setup is because then you can see that you put things in the right place.
Right.
So now we're going to take our calculator. 60 times 120 gives you 7,200. Divided by 45 gives us 160 milliliters per hour. So think about it from this standpoint. In 45 minutes, you will have administered 120 milliliters, but we can't program the infusion pump to do per minute. We can only program it to do per hour. So in an hour, you would actually, if it went a full hour, you would actually put out more milliliters. So your number should be bigger. Okay. So like if this were 120 milliliters in 30 minutes, then you would set it to 240 per hour because half of 240 is the 120 and what you're looking for. So there's a couple of different ways, but I would just say to simplify it, just remember to multiply by 60 when you're going from minutes to hours. If you're already in hours, just reduce the big number over the little number.
Please, the first Zoom drug calc meeting we had on Tuesday, did you post it on our Blackboard website?
No, let me just open this up here. So you can see that the order is the heparin 4,000 units subcutaneous. You will give how many milliliters and then circle the correct amount on the Tubex. So when you're looking at the label tells you 10,000 units per milliliter. And so what you're going to do is you're going to take your 4,000 units, which was ordered, and then you're going to convert units to milliliters, and you're going to get 0.4 milliliters. Now, if you're doing ordered over half, 4,000 over 10,000, you'll get the same answer I got, the 0.4 milliliters. Then you go to your Tubex. You will see that you have a 1.5 listed on your Tubex. And so what I did is I just verified if these are by 0.1 or by 0.2, meaning is it 2,468 or is it 1, 2, 3, 4. So it says 0.5, 0.6, 0.7, 0.8, 0.9, 1. So I know that they're each 0.1. So I went to 0.5. I went down from there to 0.4, and then I circled that on the Tubex. You probably find also marking that on the arrow, but honestly, you guys are going to be doing this. I think your test is online, so I don't know how you're going to be marking your test. So.
No, I think it's in lab.
Oh, it's in lab. Okay.
Yeah, it's in lab.
Okay. So we're looking at 24. It's a weight-based question. And before I do anything, I know it's a weight-based question because it tells me 15 milligrams per kilogram. You always have to account for that kilogram. That kilogram is always referring to the patient's body weight. Sometimes the body weight will be given to you in kilograms, but here you can see it's given to you in pounds. So let me get a blank piece of paper. So the order is Dilantin 15 milligrams per kilogram loading dose by mouth, then 300 milligrams per day for the loading dose. And that's what's important for the loading dose. How many milligrams of this anticonvulsant would you administer to a patient who weighs 176 pounds? So step one, we got to convert pounds to kilograms. Okay. So I'm actually going to set this up dimensional analysis wise. If you just automatically divide by 2.2, you're doing that right. Okay. So 176 divided by 2.2, and you get 80 kilograms. Once you have that 80 kilograms, now all you have to do is multiply by the 15 milligrams per kilogram. Okay. And then 80 times 15 gives you 1,200 milligrams.
Okay. Please, can you go over it again?
Sure. But get this. There we go. So 23 is just, you're doing two problems in one and then adding them together. You're just finding the milliliters of Visceral to administer, the milliliters of Meperidine to administer, adding them together and getting a total volume. So what I'm going to do here, I'm going to take, my order was the 60 milligrams for the Visceral. Visceral available is 50 milligrams per milliliter. So 60 divided by 50 is 1.2 milliliters. So that's pretty straightforward. You've done that before, I think. The Meperidine, you're going to do the same thing. You have 85 milligrams as the order. Available is the 75 milligrams. So I'm going to set it up exactly the same way. And then you're going to get, I think, 1.3 repeating. 1.13 repeating. And I'm just going to put a line over top to indicate that it's repeating. So here's the thing. In this question, it actually doesn't matter when you round it. So you can round it now or you can round it later. So if I round it now, I would just say it's 1.1, right? And then I would get an answer when I add these two together. I would get 2.3 milliliters. Okay. Now, what if I waited? Well, then I would get 2.3333 milliliters. And what would I do? I would round to the nearest tenth and I'd get the same exact answer.
Okay, that's not bad. Can we do a flow rate one?
Sure.
Please, can you let him do a drop rate one before we go to?
Yeah, I just did two of them.
did.
I'll come back and I'll do another drop rate question, but let me go ahead and do a flow rate question real quick, and then we'll and then I'll come back and I'll do some more drop rate questions.
Okay, thank you.
You're welcome. All right. So so for, let's just say for a flow rate question, let's say I have let's say 300 milliliters to infuse over 20 minutes. And I want to know what the flow rate is in milliliters per hour. Okay. So that's how the question will be asked. It'll say, what do I program into the infusion pump, or what does the nurse program into the infusion pump? So what I'm going to do is, I'm not going to do 300 divided by 20. What I'm going to do is I'm going to convert the minutes into hours. And how I do that is I'm going to multiply by 60.
Yes.
Okay.
And when I do that, 60 times 300 is 18,000 divided by 20, and I'll get 900. This may have been a bad example, but 900 milliliters per hour.
Yeah.
Now, here's the other thing. If in 20 minutes, 300 milliliters will go, and then how many 20 minutes are there in an hour? There's 3, right? So 3 times 300 would be 900. So you can do that a number of ways. You can do that with 15 minutes.
Wow.
How many 15 minutes are in an hour? 4. So if that's what this was, we would program 4 times 300. It would be 1,200 milliliters per hour. If it were 30 minutes, okay, 300 or 30 minutes is half an hour. So 2 halves, 2 times 300 would be 600 milliliters per hour. But if you ever get stuck, just remember 60 over 1, and that'll help you out.
Okay. Thank you.
You're welcome. So I'll give you another, since it was asked, another drop rate question. Do you want it to be, how would you like your flow rate to be? Milliliters per hour or milliliters per minute?
Milliliters per minute. And
Okay.
that's a drop rate, right?
It doesn't matter. It could be written that way, or it could be written milliliters per hour.
Okay.
It just depends on what the question, like it.
Let's take one in milliliters per minute and one in milliliters per hour.
Okay. So like what I did up here.
Yes, sir.
Okay. So let's say 180 milliliters, and let's say 20 minutes. And we have a drop rate factor of, let's say, 20. Now I'm just coming up with these. I'm just making them up. So I'm not, I'm not reading off anything, but these are common drop rate factors that I'm giving you. I've seen 5, 10, 15, 20, 25, 30, and I've seen 60. And I've also seen 100. So there's different drop rate factors, but the common ones you'll see on your tests are usually like 5, 10, 15, 20. All right. So all I'm going to do is, because of the way I write it, I know, just using dimensional analysis, I know I'm already in what I'm looking for, because I'm looking for drops per minute. So I don't need to convert anything. All I need to do is multiply across the top and divide by the bottom. Notice how these two are going to cancel out.
Mm-hmm.
So it would just be 180 drops per minute. Okay. Now, is this a good example? Meaning, like, is this something you would see in like as a real life situation? Probably not, but that's just, like I said, when you come up with things off the cuff, it doesn't always make sense. Versus, like, if you were talking about like a heparin drip, just sounds like it would be an extreme heparin drip. All right. So what about if it was milliliters per hour? So let's say 250 milliliters per hour. Well, 250 milliliters. Yeah, we'll just say in an hour. We have a drop factor of 15. And the question is, what would you program into the infusion pump in drops per minute? So again, anytime we're doing drop factor, drops per minute is the rate. Anytime we're doing flow rate, just flow rate by itself, it would be this milliliters per hour. Now, the shortcut for this is we know that 1 hour is what? 60 minutes, right? So we could just, we're just gonna, as soon as you see hour and you need to convert it to minutes, just go ahead and convert that right away. Okay. So 250 times 15 gives you 3,750 and divided by 60 and you get 62.5. Can I give them a half a drop?
The 63.
Yeah, I can't give them a half a drop.
Yeah.
So I
Whole
need
number.
to round to the nearest whole number, so 63. Now, in reality, like in a clinical setting, when you're actually doing this with somebody, you may not even be able to program it to 63. It might be 60, 65. What the reason I'm telling you that is just because when we're in the math bubble, we're just trying to do the best estimate that we can given what we know. And obviously we don't know based off of the tubing and the settings and all that kind of stuff, that would be different. But we do know we can't give somebody a fraction of a dot or a fraction of a drop. And so that's why you round to the nearest whole number.
Okay. Thank you.
You're welcome. Properly do the math setup with it. Okay. So there's two ways that you can convert micrograms to milligrams. You can just move your decimal over 3 and get 0.5. Or if you don't like to do that, you can set up an equation. So I'll just do that real quick. And we know that in 1 milligram is 1,000 micrograms. 500 divided by 1,000 is where I was getting that 0.5 milligrams. Okay. Now that I have that, now I can solve the equation. I take my order, convert it into milligrams. I take what I have available, which was the 0.05 milligrams per milliliter. And then when I do 0.5 divided by 0.05, I get 10 milliliters.